34 years ago, yeah. So anyway, I wish my little boy happy birthday today. It was, ironically, it was a Thursday, just like today. And all I was thinking that whole week was, he'll be born on Friday the 13th. I didn't want to have him on Friday the 13th. But wait till Saturday and be born on Pi Day. He didn't do either one, so that's okay. All right. All right, so here we go. What did you do first? Subtracted. And then what? Divided by 2. Now our inequalities can get a lot more complicated than this, we know that. But the one on your quiz is going to be relatively easy like this one. It's going to have some minor arithmetic involved. And then of course you're going to have to figure out what the answer is. So where does the sign equal root 3 over 2? Pi over 3 and 2 pi over 3. Right? Where is it less than that? All of this? How do we express that in an answer now? Where do we start? 0. So we start with 0 and go all the way to pi over 3, which these are closed-in dots, right? And then we start again at 2 pi over 3, and we go all the way around back to 2 pi. Now, the way these directions are written, we don't include the 2 pi. Had the directions been written this way, we would. It's redundant to include it, so I'm not sure why he does that sometimes, but anyway, there you go. That's the answer. Got it? Okay. Now, let's look at kind of an easier equation. Although, some of you did not do very well with this kind of equation on your homework. I saw a bunch of shenanigans. Do not divide by sign. Why can I not divide by sign? Because can sign be 0? Then you can't divide by 0. So don't divide by sign. Don't divide by x, don't divide by sign, don't divide by anything that can ever be 0. Okay, so what am I going to do instead? Subtract it. Take out a sign and maybe a 2. That doesn't really matter, but yeah, factor. So what am I left with? What do I do now? So sine x equals 0. Or cosine x equals 2. Where does sine x equal 0? 0 and pi. And if it's included, which it's not, but if it were included, it would have 2 pi. All right, where does the cosine equal 2? It doesn't ever. Here's your circle. Cosine is x. X is 2. It's out here. No. Cosine never equals 2. So that's the answer to the question. okay? All right, I want to point out one more thing though, because it did happen in your homework, and it kind of got threw me off guard. Just, this is not one of your problems, but a situation like this. Let's suppose you had cosine squared minus 2 cosine equals 3. It's okay to factor over here. I mean, I would because it doesn't take you anywhere. But what you absolutely cannot do then is say, okay, so cosine equals 3 or cosine x minus 2 equals 3. No, that breaking it apart like that only works when your equation is set equal to 0. Okay, I'm not making this up. People were doing this in their homework. You can't ever break an equation into pieces and set it to anything other than 0. Okay? So what would you do instead if that were your problem? You subtract the 3 over and factor it. Yeah, and then you can set them equal to 0. Okay, we got one more practice problem to do. And this one's with the calculator. So we're going to have an equation. We're going to solve with our calculator. All right, so it's a little quadratic. What do you think we ought to do first? Okay, so tan squared plus 5tan equals 0. And then I can say tangent equals 0 and tangent equals -5. Now, I can actually do that one without a calculator. Where does the tangent equal 0? Here and here. Now you need to be careful, because if you are using your calculator, he will only give you one answer, so you'll have to figure out the other one on your own. All right, and your picture might help you. Where's the tangent -5? Well, the tangent of -5 somewhere in this quadrant or this quadrant. Would you agree? What angle has a tangent of 5? I have no idea. No idea. So make sure I get radians. And the second tangent 5. And it's 1.373. So this right here is 1.373. Which means that this is also 1.373. Second tangent 5. How do I always find an angle on my calculator? Second. Now I need the answers though, because 1.373 is not an answer. What are the answers? I need this whole thing, which will be what? How can I calculate that? Okay, if you, I made that positive, so I did minus, but yeah. So it's 1.768. And and the other one is 4.910.
How did you get that again?
Yeah, which one?
So did you add, what did you add to?
Okay, well, let's look at my picture right here. Did you get 1.373?
Yeah.
Okay, so I need this angle right here. What's this right here?
Pi.
Pi. So it's
Okay.
pi minus 1.375? And then this one is also 1.373. I went all the way around, so that one I could do 2 pi minus 1.373. Okay. Now, what else could I do though, by the way, since I have my calculator? Patrick, I think you might have been doing this. What were you doing over there? Did you graph it?
That's what I'm trying to do right now. I messed up the square, so I had to redo it.
Okay, alright. Oh, yeah. So, it is definitely possible to graph this. If you have your calculator and it doesn't say no graphing, you can solve it by graphing. When you go, I don't know whether you're putting it in this way or this way, whenever you put it in, remember this means tan x squared. So your parentheses, be careful, as soon as you have to have parentheses, tan, then these are gonna come in, you're gonna close them, close those, and then square. If you're gonna graph that. That's how you would put tangent squared in your calculator. You gotta manually put in this parentheses. This will come in automatically, so close it, square it. And I don't know what, I don't wanna spend a lot of time on this because there's stuff to do, but, I don't know what this looks like. If you do that, I think it's easier to use algebraically, at least for me. That's up to you. Anyhow, that's our quiz on Tuesday, when we celebrate Pi Day and bring in something round, edible, and shareable. Let's get our notes back out, and let's pick up where we left off. And I think we're on page 2, and we're ready for number 7. So we are solving We're gonna do it, we need a calculator to get the angles, cause they're not gonna come out to be pi over 3 and that kind of stuff. Alright, so here's what we're gonna do. We're going to, let's solve this equation. Eventually, we're gonna have to go to our calculator, but let's see if we can get it algebraically first. So would you agree maybe subtract 3? And divide by negative 1.7? One over 1.7, is that 10/17? So I have this equation, this is cotangent, 0.5x minus 1 equals 10/17. Doesn't that mean that the tangent of this angle equals 17/10? If the cotangent is 1/5, and the tangent is 5/1, right? That's their relationship, their reciprocals. So when I change this to a tangent, which by the way, what would be my motivation for doing that? Because I'm gonna go to my calculator, and guess what button I don't have? Cotangent. So I'm gonna rewrite my equation in terms of a button that I do have. Okay. Now, there is some angle out there whose tangent is 17/10. Would you agree with that? We can call it anything we want, but there's an angle out there whose tangent is 17/10. Parker, how do I find that angle? Second tangent, 17/10. And that angle is 1.039. Now, before I go any further, that isn't the answer to the question. Before I go any further, is there another angle out there whose tangent is 1.039? There's this one, which is in quadrant 1, right? But isn't the one also in quadrant 3? And how would I find him? Add pi. So that angle is either 1.039 or 4.181. Now, the question said the tangent of something is 17/10. So we just figured out that the somethings are 1.039 and 4.181. Now, what is that angle? 0.5x minus 1? So your job is to figure out what x is. We have found the angle. Now we're gonna find x. So we're gonna solve this. So 0.5x equals 2.039 and 0.5x equals 5.181. And then I'll divide by a half. I got, for this one, I got 4.078, or I guess I could have done that. And for this one, I got 0.362. How does that look to you, okay? Now here's what makes this problem tricky. Notice that the directions are this. And, no, they're not. And what does that mean? That means whatever we come up with has to be in there. Is this one in there? What's 2 pi? 6. This is in there. Is that one in there? No, too big. The original angle value we got was okay, but then when you had to start doing this stuff, it messed it up. So the only answer is 4.078. Alright, let's go to the back of page 3. More unit circle stuff, but you gotta remember what these things are. So what's cotangent? What's cotangent? Cotangent is x over y, right? So x over y, here we go. What's that gonna be? 3 pi over 4.
I need a packet.
Will you go back and get one out of the thing back there?
Sorry. 4 over 3 pi. Oh, it doesn't exist? Never mind.
Okay, Charlie, I need you to lock in here.
I'm locked in.
Okay. 3 pi over 4 is an angle.
Yeah,
We do not ever
oh no.
reciprocal angles,
You're right.
okay? We reciprocal the fractions, the trig functions. So, we're thinking at 3 pi over 4, slow down your brain, at 3 pi over 4, which is right here, the ordered pair is negative root 2 over 2, positive root 2 over 2, or 1 over root 2 if that's the way you write it. So what happens when I put this one over this one?
You get -1.
Yes, and that is the answer to the question. Okay? Now this is gonna be the same thing. I'm gonna go around to 5 pi over 3. What is my ordered pair at 5 pi over 3?
That would be negative, sorry, 1/2, negative root 3 over 2.
Perfect. Now, I want the secant. The secant is the reciprocal of the cosine.
Cosine.
So I look at my cosine and I flip it. So the secant is 2. We do not reciprocal angles. We reciprocal sines and cosines, the fractions. All right, 7 pi over 6, it's right here. What is the ordered pair for 7 pi over 6? Negative root 3 over 2, negative 1/2. I want the cosecant. The cosecant is the reciprocal of the sine. So it's negative 2. Alright? So this is exactly what you've been doing on your unit circle, except now you've got to remember the definitions for your other functions. Alright. Next, we got, two functions, f and g. One of them is the cosine. And one of them is the secant. And we know that f of a, which is the cosine of a, is 0.235. So what would g of a be? Well, g of a would be the secant of a. Can we figure out the secant? It's just the reciprocal, yeah. So it's gonna be 1 over 0.235. Whatever that is, that's some decimal, you can type it in your calculator and get it. You'll have to print one. These are the extra Sorry about that. All right. Okay, next. The parent function of cosecant is stretched by a factor of 2 and shifted up 5. What's the equation for the new function? Y equals what? Two cosecant? That's not perfect. Perfect. So what would the range of this thing be? Now remember, a cosecant is the reciprocal of the sine. So the normal cosecant looks like this. When we multiply this by 2, that's going to turn these guys into 2 and negative 2, right? And then moving it up 5 is going to do what? Well, it's going to pull this point all the way up to 7. And it's going to pull this one, let's see, up 5. It's going to go up to 3. So now let's talk about the range of this thing. Negative infinity to 3, perfect, that's this piece, and then 7 to infinity, absolutely wonderful, perfect. Which of the following is equivalent to the cotangent? So in other words, which of those, if you graphed it, would look like a cotangent? Will A look like that? No, why not, Charlie?
Well, that would just be the original function flip, so it wouldn't be about the origin.
Yeah.
Or it would be about the origin.
The tangent has asymptotes at negative pi over 2 or pi over 2. So flipping it over, it's gonna have that shape, but it's not gonna be in that location. Okay. So let's look at negative tangent. So this is what I mean, this is negative tangent. Obviously same shape, not same position. But what if you took that one? Question D says, what if you took that one and shifted it pi over 2 to the right? Wouldn't that work? So I think it's B. It can't be C or D because they're not going the right direction. So B is the answer. Good job. Which of the following has no solution? A. How do I know A has no solution? Think about it. Doesn't that say cosecant equals 2/5? And if cosecant equals 2/5, then what does sine equal? 5/2? Can sine equal 5/2? No. You guys, cosecants have to be bigger than 1 or less than negative 1. Because otherwise, the sine will work. All right. 311 due on, what is that, Tuesday? Tuesday is a huge day for us. It's our Pi Day celebration, bring something around, shareable and edible, and our little 3-problem quiz, and our 311 homework is due. All right, here we go. 3.12, how cool, 3.12 on 3.12. The stars
Oh my gosh,
are
that is so
aligned.
cool.
All right, so here we go. All right, so this is kind of a big deal. Sometimes I don't talk about all the stuff he writes, but this is kind of a big deal. Here's our unit circle. And we know that some point out here, x comma y, that x and y represent the cosine and sine of the angle. So cosine theta, sine theta. If I were to build a little triangle here, obviously this is x, and this is y, and that's 1. And obviously, x squared plus y squared equals 1. Which means what? Cosine squared plus sine squared equals 1. Always called the fundamental trigonometric identity, and it is absolute fact. I did a class, I'll tell you a little story about that, it's kind of cool, but that is 100% true. Now, get comfortable with that. Remember, no reference sheets in AP Precal, so we gotta know that. Get comfortable with it though in different forms. So would you agree that's the same equation, just rearranged? And you could do the same thing with cosine squared. So just be aware, you might see this identity in different ways. If we take that identity and we divide everything by cosine squared. Now, obviously, this is only gonna work if cosine squared isn't 0. We get 1 plus tangent squared equals secant squared. See how that worked? 1 plus tangent squared equals secant squared. Now, that looks like another thing to memorize, and the more problems we do, you'll get it memorized. But for now, isn't that just another version of this? They're all gonna come from this. What happens if we divide everything by sine squared? We get 1 plus cotangent squared equals cosecant squared. These are called the Pythagorean identities. Obviously, they come straight from the Pythagorean theorem. Okay? All right, let's try example 1. All right, yeah, let's try example 1. This seems a little overwhelming. There's a lot piled in here, so we're gonna have to take it slow to get through it. But we'll be fine. We'll be fine. All right, example 1 says we have tangent over cosecant, and we are to rewrite this as just cosine. Okay, any idea on how we might do that? Charlie?
Isn't cosecant just 1 over sine?
It is.
So, if we did tan x over 1 over sine, it would actually be tan x times sine x.
Okay. Remember, the directions were, this is absolutely correct, but the directions were write it in terms of cosines only. And you, yeah,
We would take the tan and make it cosine x over sine x. Or sorry, sine x
there
over
we go, good. It's a good plan. Yeah, it doesn't fix all of our problems, but it's moving us in the right direction. So now we have sine squared over cosine, Charlie? I had it written right down here a minute ago. So sine squared plus cosine squared is 1. So what is just sine squared? 1 minus cosine squared. Now, we have the same fraction. We've just rewritten it in different, ways. But now look, it's all cosine squared. It's all cosine squared. All right. I need you to look down at the bottom of that page of notes, on the back of page 4, down at the bottom. We have a couple sets of identities. Now luckily for us, we don't have to know all of them. But you have to know these, you have to know what are called the sum and difference identities. So, what do we mean by sum and difference? We mean we're gonna take an angle and either add or subtract another angle, and we're gonna find the sine of it. So we're gonna find the sine of the sum of two angles. It is not a distributive. I wish that the sine of alpha plus beta was sine alpha plus sine beta, but that is not the case. Instead, we have a formula for it, which you're responsible for knowing. Good thing you have a 3-day weekend or some time, right? To write these on note cards, do a little Quizlet, whatever you need to do, get these figured out. All right, so here's our formulas for the sine of alpha plus beta. Luckily, the plus and minus, that's easy to handle. All right, here we go. It's the sine of the first, cosine of the second, plus or minus, cosine of the first, sine of the second. So you have a first and a second angle. He's calling them alpha and beta. That's what they're usually called, but they don't have to be. You can call them X and Y, A and B, whatever you want. Notice that if we're doing alpha plus beta, we're doing sine cosine plus cosine sine. That's what this notation means. I don't want you to get confused by that. If I wrote them separately, it would look like this. Okay, so in other words, the sign in the formula matches the sign in the problem. So again, this is if you have two angles that you are adding together, and you want to know what the sign of that sum is. This allows you to deal with angles you haven't been able to deal with until this point. Think about this for a minute. What if I asked you to find the sine of pi over 12? You can't do pi over 12. It's not on your circle, right? What is on your circle? Pi over 4 and pi over 3. So what if we took pi over 4 minus pi over 3? Does that make pi over 12? It does. So now I can do this problem in terms of two known angles and my formula. We'll practice that in a minute, but I want to get the other ones up here before we run out of time. All right, so these are the sine, sum, and difference. Cosine, sum, and difference. And I'm going to go ahead and write them separately. You do not have to. They are the same, except for their SIGNs. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. So in other words, if the angles are being added, the formula is a subtract. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. So if you look at the way he wrote them in the notes, over here he has plus minus, but over here he has minus plus. Because with the cosine formulas, they change. Your heads are ready to explode. Sorry. All right, then we finally, the last set we have, and I believe the last set we have, are the double angle identities. So what we mean by double angle identities, what are the theta? So sine 2 theta, double theta, 2 times theta, which is just a special version of this one, theta plus theta. 2 sine, cosine. double angle cosine's a little bit trickier. Cosine squared minus sine squared. But because of the whole Pythagorean thing, we can put in 1 minus sine squared. Or we can put in 1 minus cosine squared. Yeah. For the time being, I keep those handy till you get them memorized. Let's look quickly at example 2, just so you can see how this works. Which of the following is equivalent to the expression 2 sine cosine? 2 sine cosine is double sine, right? What's your theta in problem 2? Pi over 14. So you have a formula in problem 2 for the sine of 2 times pi over 14. You told me theta was pi over 14. So 2 theta will be pi over 7. So that is C. C is the answer. Sine pi over 7. I gotta stop and then take a cute little story. The year Cathedral decided to bring in calculus into the curriculum, I went to